everyone, I am Atul Negi and I welcome you all to IMS Gate Academy YouTube platform. In the Gate Booster series, today we will be talking about the thermodynamics part, and in this particular session we will be covering the whole syllabus of thermodynamics and we will be solving some important questions, and with that question we will be discussing the important concepts as well, which will be very important for your Gate examination. I hope many of you have already completed the Gate previous year question. And after that completion of previous year question, we need to solve some different variety of problems and some advanced level of problems, so that you will be on getting some extra confidence in the particular thermodynamics subject. In the last session, we have talked about the engineering mechanics session. I hope you have enjoyed that session. Whoever not attended the engineering mechanics session, they can watch the recordings. Yesterday only we have taken engineering mechanics session. So in today's session, thermodynamics will be talking about all the important concepts, starting from the first law of thermodynamics, second law of thermodynamics, Exergy, Rankine cycle, Brayton cycle, all those important concepts we will be discussing in this session. Okay, directly we'll start with the numericals here, and I hope you will be joining the session. And if you have, like previously also engineering mechanics session was done, so please share this session to your friends as well, so that they will also get benefited from this particular session, right? So we'll start the session with the numericals, and I want everyone to solve this question. Please have a calculator with you so that you will be able to solve all the numericals, because all numericals we are going to discuss in this particular session, right? So this is the question from the first law of thermodynamics, basic heat and transfer part. So I will give you the 3 minutes for such problems, because it will not take that much time, but still at least you should be getting the answer within 3 minutes, right? So your time starts now here. So you have to be very quick in solving numericals here, okay? We'll discuss the concept in detail as well. But everyone, as of now, please solve this question. They've given a piston cylinder arrangement having air at 600 kilopascal, temperature is 290 Kelvin. Volume of 0.01 meter cube, constant pressure process is there, okay? For 54 kilojoule of work output, find the final temperature of the air, okay? So constant pressure process we are having, constant pressure process. So for that work already they have given, and they are asking the final temperature of the air. So everyone please try this particular problem. Last 2 minutes, right? So such questions are very much important for your Gate examination. Parallelly with the numericals, we will be talking about the concepts as well, right? So if you have already done with the PYQ of all the subjects, now you should start solving the test series part, because with the test series you will be understand how much accuracy you are having, okay, and what is the speed, because speed and accuracy plays a very important role in the competitive examinations. Like specifically in Gate, you have to solve questions, 65 questions in 3 hours, right? So you have limited time, you have to be very quick, you need to understand which concept I need to apply, which formula I need to apply. All those things are like very, very important. So for that you need to practice a lot, specifically online test. As of now you have done the practice, you have attended the classes, you have all the class notes. Now it is the time to check your performance through online tests. Very good evening, Matan. Very good evening. So online test is the best way to understand, to evaluate your performance. That evaluation part is very, very important. Otherwise, you are just preparing without knowing how much you are able to perform. So there should be a feedback, and that feedback will be given from the test series analysis part. You will get to know about your performance from the test series analysis. So it's my advice to all of the students who are preparing for the Gate examination, please start writing the test series. It is very, very important, okay? So I hope you are able to solve such questions. Last 10 seconds we are having, okay? Please, you should be interactive in the session, so please mention your answers in the chat box as well if you have already solved. right? So it's time's up. Now please understand here what they have given. A piston cylinder arrangement is there. 600 kilopascal is the pressure and temperature they have given, okay, and a volume of 0.01 meter cube. Constant pressure process gives a 54 kilojoule of work. So what is the work we will be having? Please understand this part. They've already given 54 kilojoule of work. 54 kilojoule of work we are having. And the constant pressure work will be P into delta V. Right? Constant pressure process. What is the work done formula? Pressure into delta V. Delta V is change in volume. So pressure already they have given. Okay. So can I calculate the change in volume? Yes, we can easily calculate change in volume. So this 54 will be there. Pressure already they have given 600 kilopascal. So I will be getting the delta V value from this relation. Delta V will be getting. Now as they have given, it is a constant pressure process, and obviously initial volume they have given. Initial volume, that information is already given to us. Initial volume that we are having is 0.01 meter cube. Can I find out the V2 volume? Yes, V1 plus delta V. That will be our final volume. That's how we will get the value of V2 here. Now, final temperature of the air they are asking. Basic ideal gas relations we need to apply. I'm telling you, ideal gas equation is the most basic equation that we need to understand, specifically in thermodynamics. Many times I've seen people are doing mistakes while using the ideal gas equation itself. So just after writing this W work done, we got the change in volume. Through change in volume, final volume also we have solved. Now we need to calculate the final temperature. Basic ideal gas relation we need to apply to get the final temperature. Still I'm waiting if someone will answer in the chat box. Okay, just already have given you the hint. After this, ideal gas relation you need to apply to get the answer. So please at least try and tell me your answers, whatever you are getting. Do it fast, everyone. Ideal gas relation. Ideal gas equation, how you will write? It is P into V equals to mRT. This is the relation we are having. Okay. Now, if it is a constant pressure process, directly I can write V1 by V2 equals to T1 by T2. T1 initial temperature 290 Kelvin already they have given. T2 we have to find out. V1 already it is given. V2 we can find out. So delta V, if you solve it here, you will get very easily delta V value. And to calculate the theta2 temperature T2 value, you will be getting here T1 multiplied by V1 by V2. V2 by V1. So just you need to put the values here. T2 answer you will be getting very easily. Okay. So you need to understand, using ideal gas relation, this is relation we are having. But how to calculate V2? The data given was the work done. Work done was given. So work done given, how we can find out V2? Because from the work done, change in volume. Change in volume it is, we have calculated. So initial volume, if I add with the change in volume, we will get the final volume also. Right. So this is very important to understand how to utilize the given data. Because please understand, it's not like a process based problem. We have to understand how to utilize the data. The data is given for work done. For work done, what is the relation for constant pressure process? P into delta V. So delta V value, how I will utilize? All those basic points we need to understand. Right. So if you solve here, the final temperature that will come around is 2900 Kelvin. That will be 2900 Kelvin as the answer. Clear, everyone? Very basic problem, right? Now moving on to the next problem here, guys. See, this is again a very, very important problem. Again, basic ideal gas relations you can use and you can calculate. So heat and work topic it is there in the thermodynamics, where we will be having different work relations for different processes. So if you have practiced those topics, and like you have understood like what are the formulas for different processes for the work done case. So you can easily solve this problem. So what actually they are telling, there is a 1 mole of air at 0.5 megapascal pressure, 400 Kelvin is initially undergoes a following process, process A and process B. Heating at constant pressure till the volume gets doubled. Okay, heating at constant pressure heating is happening, and till the volume gets doubled, till that point it is having a constant pressure process. After that, what they have mentioned, expansion at constant temperature. Expansion is happening at constant temperature till the volume is 6 times of initial volume. Okay, remember initial volume. Determine the work done by the air. Okay, so let's start the problem solving this question, guys. Basic heat and work. Okay, work done formulas, if you know for all the process, you can easily solve this problem as well. But you might face some difficulty while using the relations because all the data is not given to us directly. So we have to use whatever data they have given and what kind of values we can get out of it. Like all the values, how we can solve all those things, we have to remember here. Okay, so everyone please try and let me know about your answers here. Do it fast. Again, from ideal gas relations and the work transfer formulas for different processes, you can solve this question very easily. So after completion of the GATE syllabus, more you will practice, more confident you will become. See, right? Please understand this point. Just completion of a syllabus, just completion of the PYQ questions are not sufficient to get a good marks in GATE examination. You have to practice a lot, and the best source for practicing is the online test series. You have to attempt multiple tests from the chapter level to subject level to multi-subject level, and then finally full length mock test. More you will practice, more you will learn. See, only two aspects you have to focus in test series part: number of questions you have attempted, and out of it how many questions you have done wrong. These two things you need to work on it. So graph of your number of questions that you have attempted should increase, and the number of questions that you are doing as mistake or wrong, basically that graph should decrease. So if you follow these two things, automatically your marks is going to increase. It is going to maximize by every next test. So these two aspects are like very, very important in the test. So last 40 seconds, everyone. Last 20 seconds. Time's up. Now, please understand this particular question, very important. How we will approach this question. See, the first process. So let us consider 1 to 2 processes there. Heating at constant pressure process. Constant pressure process. Till the volume gets doubled. So final volume, let's suppose V2 volume will be twice of V1. This is the information they have given. I have written all those information that they have mentioned. Now work done. How you will write work done? So let us, this is process A. So work done for process A, I will write P into delta V. P into delta V. So P into delta V means V2 minus V1. P into V2. Okay. What is V2? Twice of V1. So that will be P into V1. Now P pressure is constant, so I can write simply P1 V1. or I can simply write RT1. Now here they have mentioned 1 mole of air, so whenever mole they are talking about, I will take R bar, universal gas constant. Please understand this point. They have not given the mass, they have given the mole, so R bar I can write directly. See, this is what very important to understand. If I talk about ideal gas equation, there are 2 formats of ideal gas equation. PV is equal to NR bar T and PV is equal to MRT. There are 2 different formats. N is number of mole, here M is the mass. With number of moles, R bar will come. Okay. And what is R here? R is actually specific characteristic gas constant or simply gas constant for a particular gas. R bar divided by molecular weight. Right. And what is mass here? Mass will be written as N into N is number of moles and M is the molecular weight. Correct? So this part we need to remember. What is the value of R bar? 8.314 kilojoule per kg Kelvin. Okay, kilojoule per kilomole Kelvin. Kilomole Kelvin. But for R, the unit is kilojoule per kg Kelvin. Right. So 8.314 kilojoule per kilomole Kelvin, because here we are talking for with respect to number of moles. Here mass we are talking about. Okay, so please understand when to use this equation and when to use this equation. When number of moles they have given, I will use this equation. Whenever number of basically mass is given, I will use this equation. So don't confuse. When number of mole is there, we have to use universal gas constant. When mass is there, characteristic gas constant we have to use using this particular formula. Right? Clear? Now coming back to the question. So for process A, we have calculated the work done. This is for process A. Now coming to process number second. Okay. So let us write 2 to 3. Okay. For process 2 to 3, they have mentioned constant temperature. Temperature is constant. And what they have mentioned, till the volume is 6 times of initial volume. It means they have given V3 is 6 times of V1. Now already I have understood V1 is nothing but V2 by 2. So I can write V3 equals to 6 V2 by 2 or V3 by V2 as 3. Like this we can write. Is that clear? Instead of writing V1, I have written V2 by 2. How we got this information? Because V2 equals to twice of V1. Right. Now, constant temperature process is there. Direct formula you should remember. Right. What is the formula for constant temperature process? Work done. Work done formula for constant temperature process. It is simply, see, P V1 ln V2 by V1. V2 by V1, basically we should write V final by V initial. So always remember the formulas from initial to final state. What is the final state in 2 to 3? V3. Okay. Instead of writing PV, I can write RT R bar, because number of moles we are talking about. So R bar into T. T either T2 or T3 I can write. Right? Either T2 or T3. Because for 2 to 3 temperature is constant. What is V final here? V final is V3. Initially it was V2. So that can be written as R bar T2 ln 3. R bar into T2 ln 3. Like this we can write. Is it clear? So just we need to add both the work done and we'll be getting the total work done answer. Please tell me, is it clear how we have solved this particular work done answer? Is there any confusion or any doubt? Wherever you have any confusion or any doubt, please let me know. Okay? Tell me, any doubt or any confusion? Now, the problem is T2, where is the T2 temperature? Okay, for that again we need to see process 1 to 2. Now, as they have given constant pressure process, can I write V1 by T1 equals to V2 by T2? From where I got this relation? From ideal gas only. From ideal gas only we got this relation V1 by T1 equals to V2 by T2. Now T2 I need to write, so V2 by V1, V2 by V1 multiplied by T1. What is V2 by V1? That is 2. So we got the answer T2 equals to twice of T1. This is the value we got. That's how we have to use the given data. Please understand. So T2 equals to twice of T1. Now I can write down the total work done. Total work done is nothing but WA plus WB. WA plus WB, right? Now what is WA? Again please see, WA is RT1, R bar T1, this is R bar T2 ln3. Okay, so R bar T1, R bar, instead of writing T2 I will write twice of T1, already we have solved, twice of T1 ln3. Clear? Now take the RT1 common, R bar T1, so 1 plus 2 ln3. This is the relation. Now in this, what is the value we have to put? Only T1, which is already given in the question, that is 400 Kelvin. That's how we are going to solve the problem. So it is very important to understand the given data, how to utilize that data, right? So always remember, whatever information they have given, you should write it as a given. 1 to 2 process, pressure constant is there, and V2 equals to 2V1. This two information they have given. As it is an ideal gas, I can use ideal gas relation. V1 by T1 equals to V2 by T2. From there I got the information T2 is twice of T1. And work done is P delta V. Now problem is, we only know this formula. So if pressure is given and delta V is given, then only we can solve the work done. That is the problem. You need to understand how to modify the formulas and the relations as well. If you really want to score a good marks, right, specifically in thermodynamics subject, you need to know how to modify the formulas. You cannot remember all the formulas. The main formula is this one, P into delta V, for constant pressure process. I need to modify this formula based on the information given. So P into delta V, V2 minus V1. Okay, V2 is twice of V1, so P1, V1 it is there. Instead of writing P1, V1, I will write RT1. Because the data for P1, V1, let's suppose it is not given, temperature is given. So with alone temperature, with only information of T1, we will get the answer. Are you able to understand this? That's why it is very important to understand how I will modify the relations. Only we have to remember the main relation. After that, some modification I should be able to do it. Clear? So like this, if you add, you will get the total answer. And the total answer is coming around 10632. Approximately 10632. Okay. Approximately 10632.69 kilojoule. This is what the work done answer we are getting. Is that clear? So again I am repeating, the ideal gas relation is very, very important. Very, very important. Okay. And for ideal gas air, like if I am talking air as an ideal gas, for that what is R value? 0.287 kilojoule per kg Kelvin. Those information we should remember. Apart from that, there is one more thing that we need to know. That gamma, ratio of specific heat, Cp by Cv, R equals to Cp minus Cv. And if I have to write Cv, I will write R by gamma minus 1. For Cp, it will be gamma multiplied by R upon gamma minus 1. This information, this relations we should remember. Okay, this informations, it is what very, very important. Is that clear, everyone? Right. Now, coming to the next part here. So this much information is clear to everyone. Now, very important, before moving forward here to the next problem, we need to understand the process, how we will write the process in thermodynamics. This is called as polytropic process. based on the values of n, we will have different processes, and for that how we will draw the graph, it is very important to understand. Because maximum time you will understand the processes or given, sometimes diagram only given, so from the diagram we need to understand the process as well, or when the information is given we should be able to draw the diagram of that particular process. So that's why the graph is what very important here. So let's suppose this is volume, this is pressure. Let us draw the coordinates here. Okay, now see. So it is a polytropic process. So let's suppose n value is 0. There is n value, there is another possibility. When n value is 0, what will happen? Pressure equals to constant. Okay, when n value is 1, what you will be having? Think about it. N value is 1. So you will be having temperature constant. You will be having temperature as constant. Now n value equals to gamma. You will be having adiabatic, reversible adiabatic process. Reversible adiabatic process. And finally, if n value, okay, if n value is infinity, so you will be having constant volume process. Constant volume process here, right? Now, how you will draw? First of all, constant pressure process. This is the constant pressure process, P equals to constant. Then we have n equals to 1. This graph we will be having. Then n equals to gamma. Okay, so this is constant temperature process. This is reversible adiabatic. How to represent adiabatic process? Pressure into volume to the power gamma is constant. And then finally you have constant volume process. Now here very interesting thing that you need to understand, in the clockwise sense n value is going to increase. In the clockwise sense n value is going to increase. N increases in the clockwise sense. N value increases in the clockwise sense. So this is very important. So this information is very important, right? So this is a general way of representing the process. So this is called as polytropic process. Clear, everyone? Now one more thing after this. Okay, before moving to this problem, one more important detail. For isentropic process, which is also called as reversible adiabatic or reversible adiabatic, there is a relation that we need to remember. T2 by T1 equals to P2 by P1, or better you should write it like this: T final by T initial. T final by T initial equals to P final by P initial to the power gamma minus 1 by gamma equals to V initial by V final to the power gamma minus 1. This is very important relation for isentropic or reversible adiabatic process. Okay, very important relation. So why I have written in terms of initial final states, so that you will never confuse regarding how to write this relation. Right. So this is a very important part you need to understand. Done for reversible adiabatic or isentropic processes. Done. Now coming to the problem here. Next, this problem. This is very important problem from the mixing of fluids. Basically they have mentioned there are two gases A and B, right, having equal number of moles expands isentropically in a nozzle. The mixture of gas enters the nozzle at 300 kilopascal and 350 Kelvin and exits at 120 kilopascal, assuming the mixture to be an ideal gas. Now for mixture to be behaving as an ideal gas, they have already informed this point. Now if mixture is behaving as an ideal gas, I can use the relations which is applicable for ideal gas. But for mixture, I need to know how to calculate the molecular weight of the mixture, characteristic gas constant of the mixture, or all other parameters. Okay, so those calculations for a mixture we should know how to calculate, right? So let's get started in this problem, everyone. I will start the timer for you. You have 3 minutes to solve this question, right? You have 3 minutes. Okay, take 4 minutes because there is small lengthy calculation is there. Everyone should try and tell me your answers. Mixture related problems. So this is again very important topic of GATE. Okay, from the thermodynamic subject, this mixture related problems are very important. So they are asking the temperature of the gas mixture at the exit. Now isentropic process they have mentioned, fine. So directly I can use this relation. But the problem is gamma is not given. Gamma of a mixture we have to find out first. I have given you the hint also. I can directly use this relation T2 by T1, P2 by P1 to the power gamma minus 1 upon gamma, because initial pressure and exit pressure they have given, initial temperature they have given, final temperature we can solve using this relation. But where is gamma? We have to solve this gamma first. Okay, we have to solve gamma and then only we will be able to get the answer of T2. So just think about how you will get the answer of T2 here. Gamma value first of all. They have given the individual CP, specific heat values. Can I calculate specific heat of the mixture using the values of CP? Just think about it. CP value of the mixture, if you are able to calculate, you will get the answer of gamma also very easily. Because CP of mixture will be equals to gamma times of R mixture, gamma minus 1, like this. So CP mixture I need to calculate, R of the mixture we have to calculate, then I will get the value of gamma. Just think about it, everyone, first. Last 40 seconds, everyone. Last 20 seconds. Okay, now time's up. This is really a very good problem. First of all, we'll understand, as I already told you, gamma is the first thing that we need to calculate. Cp of a mixture equals to gamma upon gamma minus 1 R mixture. Now, why we are talking about Cp of mixture? Because the values they have given for Cp of a individual gases. For mixture, we have to use this formula to calculate. Now, to calculate Cp of mixture, what I will do, see. This all formulas are like very, very important. Mass of gas A into molecular weight, okay, the Cp value, Ma Cp of gas A plus mass of gas B, specific heat of gas B divided by Ma by Mb. Ma plus Mb basically. This is the formula we are having, Cp of mixture. Mixture related problems are very, very important, okay. Now, mass, how you will write mass? Mass equals to number of moles into molecular weight. This is the formula. Now, if you see the question, the information is given, they having a equal number of moles, fine. Molecular weight it is given for gas A 28, for gas B it is 2. Okay. So, for gas A, if I have to write mass, I will write first of all molecular weight. What is the molecular weight of gas A? 28. 28 into number of moles. Now, number of moles are same, it will get divided actually. I will keep n, let's suppose for example I will keep n number of moles are there. Same n number of mole is there for gas B also, okay, fine. So, number of moles, first I should write number of moles multiplied by the molecular weight 28 into Cp value of gas A is 1 plus mass of gas B, n number of molecules, n number of moles, same for gas B also. What is the molecular weight of gas B? 2 into specific heat of gas B, that is 14, right, like this, divided by mass again, n into 28, then we have n into 2, like this. So, from here you will get the answer of specific heat of the mixture. In a similar way, you have to calculate R of the mixture, okay. How to calculate? Na multiplied by molecular weight, okay. Or basically first of all, in order to get R mixture, what you will do, you will calculate molecular weight of the mixture directly. Molecular weight of the mixture will be Na Ma plus Nb Mb divided by Na plus Nb, right, like this. So, just you will put all those values here, you will get the answer here, right. So, first of all, Cp of a mixture, everyone should calculate. Everyone should calculate Cp of the mixture. Cp of mixture. So, this is 28, okay. 28 it is there, and then 14 into 2, again 28 divided by it is 30. So, it is coming around 1.8. 1.8667 approximately. Now, number of moles for A and B both are same, directly molecular weight of A and B plus A plus B divided by 2. What is molecular weight of A and B? 28 plus 2. 28 plus 2 divided by 2 directly. That will be approximately 15. Right? Like this we will be writing. Yes or no? Is it clear, everyone? Is it clear? Very basic point. The mixture related problems are very important. I've seen many people are confused how to write Cp of mixture, molecular weight of the mixture. Now, number of moles are same in gas A and B, so Na and B will get cancelled out. So, here 1 and 1 plus 2, molecular weight of gas A it is given 28, for B it is given 2. 1 plus 1, that is why it is coming to here. So, 15 is the answer. Now, how to use this data? As I already mentioned here, Cp of mixture is gamma upon gamma minus 1 R mixture. Now, R mixture is nothing but R bar by molecular weight. Just now we have written the formula here. Please see. Characteristic gas constant will be written as R bar, universal gas constant divided by the molecular weight. So, that one only we have to use here. Okay. Now, let us write here. Cp of the mixture equals to gamma upon gamma minus 1 into R of mixture. Okay. So, Cp mixture gamma upon gamma minus 1 multiplied by R mixture, that is R bar, universal gas constant, divided by molecular weight of the mixture. From here, this information I will be getting for gamma, but no need to calculate individual value of gamma. Directly gamma minus 1 upon gamma I will use. Gamma minus 1 upon gamma, this information I want. R bar value 8.314, molecular weight of the mixture 15, Cp of the mixture we have calculated 1.88, 1.8667, 1.667. So gamma minus 1 upon gamma we will calculate from here. So it is 8.314 divided by 15 multiplied by 1.8667. So it is coming around 0.296. 0.296 is the value. Now this value we have to use where? In the isentropic relation. In the isentropic relation we have to use this value. So T final by T initial, P final by P initial to the power gamma minus 1 upon gamma. So T final value. So what are the values here? We will calculate. First of all, pressure they have given initially 300 kilopascal, and after it is after exit it is 120. So 350 by 120 to the power 0.296 into T initial. T initial was 350 Kelvin. Okay, so here sorry. So TF value you will be getting just by multiplying these values. So 350 divided by 120. Okay, we have to calculate the value here. Just we'll put the value which is given as 0.296 into 350. So approximately you will be getting around 266.85. Okay, 266.85 you will be getting as the answer. Is that clear, everyone? 266.85. So one important thing, this 300 kilopascal and this 350 Kelvin is at the entry and exit at 120 kilopascal. So exit, that is final pressure, we should write it here as 120 because final condition is 120, right? Initially it was 300 like this. Okay, so make sure that correct values you have put in the relation, otherwise you will be getting wrong answer. So you will be getting approximately 0.296 to the power 120 divided by 300 to the power 0.296 multiplied by 350. Okay, so 266.85 something it is coming. So make sure that you have put correct values. P final corresponds to P initial. So that's why initially when you have read the question specifically in thermodynamics, you need to mention the given data here itself. So then in that case you will never do any wrong calculations. Wrong calculations also, you will never put wrong values in the relation. Actually maximum time in thermodynamics it happens, like we will put wrong values. So initially itself you should write, okay, entry time, that is initial pressure was 300 kilopascal. Exit time, that is P final pressure. P final pressure is 120 kilopascal. So once you have written here, you will never put, instead of P final you have put P initial. That thing will never happen. So that's why you have to put all the values given data here itself. And T initial, that is 350 Kelvin. And T final they are asking. So like that you will never do mistakes here if you put all the data initially itself, initially while solving the question. So given data, writing given data is very important. Otherwise there will be chances of mistakes. I am telling you this part. So hardly it will take 10 seconds to write the data. So once you have read whole question, you have understood how to solve it, you are confident enough, yes I will be solving this question, write down the given data. Otherwise putting all those effort, putting wrong values, finally all the effort will go waste then. Now this problem from the again work transfer part, very important problem, very important. and specifically piston cylinder arrangements, there are n number of variety of problems are possible. But if you have understood the concept, what will happen in a piston cylinder arrangement, no matter whatever variety they have given, you can easily solve the question, right? You can easily solve the question what actually happens. And if you know the concept of quasi-static process, what is the concept of quasi-static process, guys? According to concept of quasi-static, the process will proceed in such a way that it will always pass through an equilibrium state. It will always pass through an equilibrium state. So that is called as quasi-equilibrium or quasi-static process. So if you have understood the fundamentals, the basics of quasi-static process or quasi-equilibrium process, you will never do mistake in piston cylinder arrangement. And I am giving you a hint here also, very important. While solving piston cylinder arrangement, you need to understand what kind of process it will have. If you have understood the process, accordingly you will draw the diagram and you will get the answer whatever they are asking. So understanding of a process and accordingly correct relations if you are using, you will get the right answer. So for this question I will give you 4 minutes. Try to attempt this question and solve this particular question and tell me your answers in the chat box also. Everyone should try this question and let me know about your answers in the chat box. Do it fast, everyone. You need to understand first of all the process that will happen in the system, because what they are asking, specific work done by the air during the process. And what is happening? Cooling is happening in the system. And I know that is the very basic question, whether piston will move in the upward direction or downward direction. I hope that one everyone knows. Very basic thing. Cooling is happening, piston will go down, right? You have to understand what kind of process it will be having. Then only you will be able to write down the work done. This is also 1 meter, this is also 1 meter. Last 2 minutes, everyone. Try to attempt this question, guys. Last 1 minute, everyone, guys. Understand the process that will happen in this case. Last 30 seconds. Time up, everyone. Tell me, is there anyone who has solved this question? See, I know like you might face a difficulty in solving this question. As I told you, the process, understanding of a process is very important here. Let us understand this question here and then we'll move to the solution part as well. So what is happening? So let us write down the state 1 here. Condition, the state 1 they have mentioned. Pressure is 150 kilopascal. Temperature is 400 degrees Celsius. Now this setup is allowed to cool, okay fine, to the ambient temperature of 20 degrees Celsius. So basically state 2 will be what? Temperature equals to 20 degrees Celsius. Right, we have to calculate what the work done. Now what will happen is the cooling will happen, heat rejection is happening, it means cooling is happening, piston will move downward. So it will move downward, it will move down. Here it is a stoppers, right? It will stop here actually. After that it cannot move further. It cannot move further once it has touched the stoppers, right? Now let me just draw the graph here for you so that you will understand how actually it will, what will be the graph here actually. From the graph you will understand the process much more clarity you will be getting from the graph part itself. Okay, now this is pressure, this is volume. Now when the piston is moving downward because of the cooling process, the pressure will remain constant. So at constant pressure the piston is moving downward. So as I told you, what is quasi-static process? Quasi-static process means the system will proceed in such a way that it will always pass through an equilibrium state. So here also equilibrium is there, then small equilibrium, one more equilibrium, and like that an infinite number of equilibrium states will be there through which the system will pass. So when it is moving downward, the pressure will remain constant. Pressure will remain constant. Okay, remember this point. It will be moving in the downward direction with constant pressure only, right? So let's suppose it has moved from state 1 to finally till which point it can move? Till this point only. Till this point it will move, right? So let us write that point as 2 dash. After that what will happen? Constant volume, because after that piston cannot move now. Once the piston has touched the stopper, after that it cannot move. What kind of process will be happening in the system? What kind of process will happen in the system? Tell me, just think about it. When the piston reaches to this point, what will happen? It cannot move further. What will happen to this one? This is a constant volume process because the volume is not changing. It is a constant volume process. Please understand, this is very, very important part. Right. So till the stopper it has touched after this constant volume process. Let's suppose write it as 2. Here constant pressure process, P equals to constant. Here constant volume. Like this. Is that clear, everyone? So during the cooling process, constant pressure, not always, till the stopper it has touched, till the stopper point. Now in this case, if they are asking work done, what is the work done? Obviously for constant volume, work done will be 0. All the work done is because of the constant pressure process, because during that constant pressure process only volume is changing. During that constant pressure process only volume is changing. Now to calculate the work done, what you will be writing? Pressure P multiplied by change in volume. So initially volume was V1, now volume is V2 dash. Like this you will be getting the answer. Now volume is not, how to calculate the volume? Volume is not given here. Okay, so what we can do, instead of writing volume P V1 and here P V2 dash. So what you can write, instead of P V1 you can write R T1 and here you will write R T2 dash. So basically R T1 minus T2 dash. So T1 it is already given. How to calculate T2 dash? How to calculate T2 dash? T2 dash you can calculate as pressure is constant. So you will write a ideal gas relation for constant pressure process. See, for pressure equals to constant, you have a relation V1 by T1 equals to V2 by T2. Now we are talking about T2 dash. We are talking about T2 dash, so V2 dash. Okay. Now, how to write V1 and V2 dash? See, V1 means this is the complete whole volume, V1. That is V1 volume. Now, if I say what is V2 dash? This is V2 dash. Now, they have given the height, assuming area is to be like some area A we have assumed. Can I say this area is, this volume is half of the total volume? It is very easy to understand, right? This total volume is, let's suppose 1. What will be the volume of this much part? This much part volume will have 0.5, that is half of 1. So 0.5. So V2 dash we will write it as 0.5 and V1 as 1. It is very easy to write. So T2 dash we have to write, which is V2 dash by V1 multiplied by T1. Now, as I already mentioned, V2 dash is nothing but half of V1. Half of V1. So V2 dash by V1 will be nothing but half. So that T1 value they have given as 400 degrees Celsius. So from here T2 dash you will be getting, and after getting this T2 dash, you will put T2 dash value here and you will get the answer very easily. So just everyone please do the calculation here and let me know about your answers. Do it fast everyone. Do the calculation and let me know about your answers. Do the calculations everyone. So 400 plus 273 we have solved, it is 673 divided by 2, it is coming as 336.5 Kelvin, right? So work done answer we will get it here, because R T1 minus T2 dash, T1 was 400 only, R 0.287, 673 minus 336.5, right? So 673 minus 336.5 multiplied by 0.287. So it is coming around something 96.5, okay, 96.57 kilojoule per kg, Now you should understand this point, very basic point, whether this is a positive work done or negative work done. We should write it as a positive work done or negative work done, tell me. It will be a negative work done. Why? Actually I have written work done as P into change in volume. Change in volume, change means what? Final minus initial. Always keep in mind this point. Change is always final minus initial. So ideally I should write V2 dash minus V1. Initially volume was V1. Because of the cooling happens and the piston moves down, final volume is V2 dash. So already I know as atmosphere air is performing some work on the system, right? So it is the work done on the system. So answer would be negative here. Okay, we have to use the negative sign here. It is means work done on the system. So ideally you will get the answer as negative only. There is no need to write negative also. What I have done here, change in volume. So just to write change as positive, I have written V1 minus V2 basically. Otherwise change how you will write final minus initial, na? So final is V2 dash minus V1. If you put it like this, you will be getting T2 dash minus T1. So answer will be automatically negative. So already just by reading the question itself you will understand whether the answer is positive or negative. See, positive negative means what? Positive it is coming simply means work done by the system, and if we are talking answer is coming negative for work done, it is work done on the system. Is that clear, everyone? Very basic problem. So quasi-static process, you need to understand. System will proceed in such a way that it will always pass through equilibrium states. So when the piston is allowed to cool, it will move in such a way that always the pressure will remain constant. Pressure will start dropping once it has touched the stopper. Further movement is not possible. Then thereafter the pressure is going to reduce. Thereafter pressure is going to reduce. But till the point the piston is moving and it has not touched the stoppers, the pressure will remain constant. Pressure will remain constant. This is a very important concept here in piston cylinder arrangements. Right, I hope this is clear. Now, a very important formulas and the relations we are going to write here. In this column, we will write the processes. Okay, and we will write here work done formula, or we can write ideal gas relation. Ideal gas relation and work done formula here. So process, if I talk about first, constant volume. I am talking about a closed system work done, right? So ideal gas relation means P1 by T1, or P by T ratio constant directly we should write. P by T ratio is constant. Work done will be 0 for closed system work. Right. Then we have constant pressure process. Phi by T ratio constant. Work done will be pressure into change in volume. Change in volume means V final minus V initial. Final minus initial. That is what the change means. Third, constant temperature process. So what you will write? Product of pressure into volume is constant. Work done. What is the work done? Pressure into volume into ln. V final minus V final divided by V initial. V final divided by V initial, right? Instead of writing V final by V initial, you can also write P initial by P final. P initial by P final. This one also you can write. Now coming to the fourth one, that is reversible adiabatic process, that is P into pressure to the power gamma equals to constant. Representation of reversible adiabatic process. So in this case, how you will write down the relation? Again, relation is this one only, like P1 V1 to the power gamma, P2 V2 to the power gamma. Work done formula, P1 V1 minus P2 V2 divided by gamma minus 1, like this. This is the work done for reversible adiabatic. If I talk about polytropic process, process will be represented as P into V to the power n equals to constant, and the work done will be P1 V1 minus P2 V2 divided by n minus 1. That's it. Nothing, any change compared to polytropic process. So closed system work done formula you should remember. Closed system work done formula, how you are writing it? Integration of PdV. Okay. For open system work, how you will write open system work? Open system work is written as minus integration VdP. Okay. Closed system work integration PdV, and open system work is minus VdP, integration of minus VdP. So for constant volume process, the work done will be written as C V P initial minus P final. Here constant pressure process, work done will be 0. For constant temperature process, work done formula will remain same. Work done formula will remain same. For open system and closed system, if the process is isothermal or temperature is constant, work done will remain same. Okay. Work done of closed equals to work done of open for isothermal process. For isothermal process. Now coming to this polytropic process part, or reversible adiabatic process, right? So how you will write here? See, gamma by gamma minus 1 multiplied by P1 V1 minus P2 V2. You need to understand open system work in this case will be written as gamma times of closed system work. Open system work is gamma times of closed system work for this reversible adiabatic process. I hope all the formulas are clear to everyone. All the formulas are clear. Tell me, yes or no, is it clear? Right, and one more important formulas that we need to write here is regarding change in internal energy. And these relations we are writing for ideal gas. For an ideal gas. So delta U mCV delta T, change in enthalpy delta H mCP delta T, no matter whatever the process is there. No matter whatever the process we will be having, change in internal energy, change in enthalpy we will be calculating like this. Remember, for an ideal gas only, for only ideal gas, these relations are applicable. Delta U equals to mCV delta T and delta H equals to mCP delta T. Now, coming to next important part, for an ideal gas, okay, if I talk about, we are talking about ideal gas only, if temperature is constant. If temperature is constant, right? So what will happen? Delta U and delta H equals to 0. Remember this part. Because internal energy is a function of temperature only for an ideal gas. For an ideal gas. This is very important part. Is it clear, everyone? So these are the basic details that we need to understand. Okay, this is what the basic details that we need to understand. So for an ideal gas only, we have written these formulas, right? For an ideal gas only case. Clear? Anything that you want to discuss, any doubt you are having, so please ask. Okay, these are like very important. Correct? So sometimes they will ask the heat transfer. So from first law of thermodynamics, you can calculate that heat transfer also. First law of thermodynamics. Del Q minus del W equals to change in internal energy. That is what the formula we are having. Okay. For calculation of the heat transfer, you can calculate, because work transfer already we have solved. All the formulas we have written for work transfer. So change in internal energy, from here you can calculate, and finally you can easily get the answer of heat transfer as well from here. Okay. Now for polytropic process, directly this formula you should remember for polytropic process. Heat transfer formula, gamma minus n upon gamma minus 1 multiplied by P1 V1 minus P2 V2 to divided by n minus 1. This is the formula that please you should remember for polytropic process. Heat transfer. Heat transfer formula. Gamma minus n upon gamma minus 1 into P1 V1 minus P2 V2 divided by n minus 1. Or better you should write initial and final, otherwise when a process is 3 to 4 or 5 to 6 something else, you might get confused also. Better write always initial and final things. It would be then very easy for you to understand also. P initial, V initial, P final, V final. Okay, and actually this is nothing but the work done formula. This is our work done formula only. Okay, this is work done formula. So you can write gamma minus n upon gamma minus 1 into formula for the work, but that work formula for closed system. Okay, that heat transfer also we are writing for closed system only. So please understand, using first law of thermodynamics you can calculate the heat transfer. If you have calculated work transfer, if you have calculated internal energy change, you can easily get the answer of heat transfer using first law of thermodynamics very easily. So this is the separately I have written this formula for polytropic process for heat transfer. Gamma minus n upon gamma minus 1 multiplied by work transfer in the closed system, which is P1 V1 minus P2 V2 divided by n minus 1. Instead of writing P1 V1 and P2 V2, I have written P initial V initial minus P final V final divided by n minus 1. That's it. Correct, everyone? Now moving to the next problem here. Again, very important problem from the first law of thermodynamics, but from open system, steady flow energy equation, SFE. Okay, steady flow energy equation. So from that this question is there. So I will give you 4 minutes for this one. Okay, so if you read the question here, first of all, they've mentioned a carbon dioxide enters an adiabatic rigid nozzle steadily at 1 megapascal and 500 degrees Celsius. Mass flow rate they've given 1.5, inlet area of a nozzle 40 centimeters square, and the exit velocity 10 times of that inlet. CO2 can be considered as an ideal gas with gas constant 0.1, gas constant they have given, and a ratio of specific heat. Exit temperature they are asking. Very easily you can solve it just by applying the steady flow energy equation. Whatever data is not given, that you have to calculate based on the information given. So first of all, please write the given data. Then only you will understand how to utilize that data to get the final answer. Okay, write down the given data first and then start solving it. Do it fast, everyone. Try everyone this question from steady flow energy equation. Steady flow energy equation we have to use here. Last 2 minutes, everyone. Last 1 minute, everyone. You have to use steady flow energy equation. See, first of all, the given data we have to understand here. They are talking about a nozzle here. Okay, let us draw the nozzle part here. This is inlet and this is exit. For example, enters at 1 megapascal pressure. So let us write P1 as 1 megapascal and T1 as 500 degrees Celsius. Mass flow rate they have given 1.5 kg per second. Inlet area they have given 40 centimeter square. Exit velocity, so let's suppose inlet velocity C1, exit velocity C2, which is 10 times of C1 they have mentioned. Okay, fine. Gas constant. Okay, gas constant they are talking about R. Characteristic gas constant 0.19 kilojoule per kg Kelvin. After that they have given a specific heat, that is 1.29. Ratio of specific heat as 1.29. Exit temperature they are asking. Aditya, you are saying velocity at 1. Velocity at 1 we have to calculate. See, Aditya, understand, they have given velocity, outlet velocity 10 times of C1. It means C1 will have some value. So we have to think immediately ki how to calculate C1. That is very good question, because sometimes in some problems what will happen? They will neglect the velocity, inlet velocity they will neglect. But they will mention this point in the question. Okay, inlet velocity is neglected. But when they have given information that outlet velocity is 10 times of inlet velocity, how you can neglect the inlet velocity? So immediately you have to think about how to calculate inlet velocity. How to calculate inlet velocity? Just tell me, Aditya, how you will calculate inlet velocity? What will be your approach? How to get the inlet velocity? What you will do? Which relation, which formula you are going to use here? So just check in the inlet what data is given, which data will help you to calculate the inlet velocity C1. See the data. Pressure, no. Temperature, no. Area, mass flow rate. Can I use mass flow rate, area, anything? Ideal gas. In ideal gas equation, where is the velocity? PV is equal to MRT. In that relation, there is no velocity, na? How you will calculate? What you will do with the ideal gas equation? We want to calculate velocity, right? See, mass flow rate equals to what? Density into volume flow rate. Volume flow rate is nothing but area into velocity. Yes, absolutely, mass flow rate, Aditya, correct. But to calculate the answer of C1, we need to know the ρ1 value. So from here, P equals to rho RT1, ρ1 RT1. So pressure P1. So ideal gas equation we will be using here to calculate the ρ1 value. Absolutely correct, Aditya, absolutely correct. So P1 equals to ρ1 RT1. ρ1 value we will be using here and we'll put it here finally. P1 value 1 megapascal, that is 1000 kilopascal into R1 value 0.01, 0.19 and into T1 temperature. T1 temperature they have given 500 degrees Celsius. So in Kelvin 500 plus 273. Calculate rho 1 value, put that rho 1 value here in this equation to calculate C1. Tell me the C1 answer first. Aditya, tell me the C1 value. What will be the C1 value here? Do it fast, all the calculations. It is coming around 6.8087 kg per meter cube. Mass flow rate value they have given us 1.5. Into area they have given 40. 40 into 10 to the power minus 4 we have to write, because SI unit we have to write. What is the C1 answer, Aditya? Tell me C1 answer. C1 answer, Aditya, what is the C1 answer? Tell me. Is it 55.07? Just please cross check the answer. 55.07 it is coming. Because that is what the main data we need. After that, directly you will apply the steady flow energy equation. Yes, 55. Yes, approximately 55 you are getting. Now the steady flow energy equation, how you will write? See, this is the standard format of steady flow energy equation that you need to remember. All terms we have written in terms of kilojoule basically. Now heat transfer, work transfer, they have not mentioned anything. We will take it 0. We will take it 0 here. Potential energy change, they have not talked about anything, so we'll take it 0. Change will be 0 because no information is given in the question. Directly I will write the equation here. H1. So let us take H2 minus H1 on the left side. So it will be H1 minus H2. Here it will be C2 square. Okay, C2 square minus C1 square. Or you can better write it in this way because we have to calculate temperature. Na? So H2 minus H1 as it is. Here I have used negative sign, C1 square minus C2 square. So it's up to you, like how you want to use it. It's totally up to you, right? Divide by 2000. So in either way you can do it, you will get same answer. There is no problem. So what I have done, H2 minus H1, keep it here. This part I have taken on the other side. So C1 square minus C2 square will be there because of the negative sign. Now H2 minus H1 will be Cp T2 minus T1. Okay. This is C1 square. C1 square. What is C1 square? 55. 55.07 square minus 10 into this one. So it would be 550.7 whole square divided by 2000. So please do it fast. T1 temperature already we have, it is given in the question actually, 773. What is the T2 answer? 322.79. What about Cp? Cp they have not given, so how you will use it? Cp will be written as gamma into R upon gamma minus 1. Okay, remember this thing, this formula directly. I have already mentioned. So gamma value is 1.29 multiplied by R value, that is 0.19 divided by 0.29. So it is coming around 0.84 kilojoule per kg Kelvin. So this value we have to put it here. This value, okay, Cp value is 0.8451. So let us write it here itself, 0.8451 multiplied by what is the answer? We have to calculate T2. T2 minus we have here is 773 Kelvin equals to this calculation. So in terms of Kelvin, what is the answer? You already calculated. Great, superb, Aditya. It is coming 595 approximately. In terms of Kelvin, it is 595. Okay. 322. Yes, absolutely. Your answer is correct. Absolutely, that is correct answer. 595 Kelvin approximately it will be coming. In terms of degree Celsius, 322 it is correct. Okay. Approximate answer is 595.36 Kelvin. Then in terms of degree Celsius, your answer is correct, 322. Now moving to the next problem. Okay. Now Aditya, solve this question. Heat engine working between temperature 840 degrees Celsius, temperature of surrounding 20 degrees Celsius they have mentioned. Engine receives the heat at 2 into 10 to the power 4 kilojoule per minute. And the measured output of the engine is 0.12 megawatt. Determine the irreversibility and second law of efficiency. This is very important. Second law of efficiency. So do it fast. You have 3 minutes for this question. You have 3 minutes for this question. Do it fast. TDS. So directly basic second law of efficiency you can calculate. First of all, irreversibility part you have to calculate, and then second law of efficiency. Try this question, Aditya. Tell me your answer. Last 1 minute you are having. Last 5 seconds. See, now please try to understand how to approach such kind of problems, right? Engine working between 840 degrees Celsius. So let us mention it here like this. (840°C). Temperature of surrounding 20 degrees Celsius. Engine receives heat at 2 into 10 to the power 4. Okay, so let us write here QH as 2 into 10 to the power 4 kilojoule per minute, right? Obviously it will perform some work, okay? And the measured output of the engine is 0.12. Measured output means the actual output is 0.12 megawatt, which means 120 kilowatt, correct? Now what they are asking, determine the rate if irreversibility, rate of irreversibility it is there, determine the rate of irreversibility and second law of efficiency. Irreversibility, how you will calculate? Irreversibility is simply the difference of reversible work and actual work. That is what the reversibility. Irreversibility, you can consider it as a lost potential. Please understand what actually we are getting by the difference. Reversible is the maximum possible work it can perform, but it has performed actual work which will be less than the maximum possible. So what is the difference? Difference is the lost potential. I is the lost potential. Understood na Aditya now? Correct? No issue. So that's why in such sessions you will understand different variety of problems also. You will get to know about the concepts in more detailed way. So lost potential it is there. Actual work they have given. Reversible work, how I will get it? If I assume the Carnot cycle case. Okay, Carnot or reversible I can say. Reversible efficiency is 1 minus T lower by T higher. That I will equate with reversible work divided by the QH value. QH value in terms of kilowatt I have to write 2 into 10 to the power 4. Minute means in terms of second I need to write kilojoule per second. So minute in terms of second 60 seconds. So like this I will be writing. So 1 minus TL. TL we are having as 40. Okay, so directly we will write it here. 40 plus 273 and this is 800 plus 273. What is the reversible work? Do the calculation and tell me your answer of reversible work. What is the reversible work answer? Reversible work answer, Aditya, tell me. If you have calculated reversible work answer, please tell me. Carnot efficiency, okay, Carnot efficiency, okay, fine, but we want to calculate reversible work, right? That is what required. Then only we will get the answer of irreversibility. Give me the answer of reversible work done. Carnot efficiency is correct, 70.8, you are getting correct answer. But the point is, what will be the reversible work done? Tell me. Yes, yes, solve it fast. 236 you are getting. No, in kilowatt we want the answer. In kilowatt terms. What is the answer, Aditya, in terms of kilowatt? In terms of kilowatt, and then irreversibility formula we will be using, and second law efficiency is nothing but very simple point, actual work divided by the reversible work. From here you will get the second law efficiency very easily. Tell me the answer of second law efficiency from here. You will easily get the answer. So second law efficiency, you should remember the formula here very easily. Is it clear? Tell me first of all, Aditya, is it clear how to calculate the second law efficiency? This formula is like very, very important. Okay. So second law efficiency, actual work divided by reversible work if it is a case of heat engine, which is a work producing device. If it is a work consuming device, in that case reverse will happen, because actual work will be much more than the reversible work. Understand the difference between work producing devices and work consuming devices. Work producing and work consuming devices you need to understand, right? So if it is a work producing device, so here you should write for work producing devices like heat engine, work producing device, heat engine or turbines, like that. Clear? Like that you can easily solve. Okay. Got it? Now, so small change you can do it here. This was 400 degrees Celsius. That's why you will not get the exact answer which is matched in the option. So this is 400 degrees Celsius. So the small printing error was there. Okay. Small printing mistake was there. So it is 400, not 800, right? 800. So if you put 400 here, so you will be getting approximately as 178.3 kilowatt, and actual work done was 120 kilowatt, reversible was 178.3. Accordingly you will get the second law efficiency. So 120 divided by 178.3, so that will come around 67.3%. Okay, small change. Yes, obviously always it will be more than 1. Efficiency will be more than 1. No, it is less than 1, Aditya. COP we will say. COP is always sometimes more than 1 or less than 1 also, depending upon the refrigerator or heat pump it is there, efficiency will be less than 1 na. So 40 degrees Celsius was the lower temperature reservoir, and 400 was the high temperature reservoir. Correct? Now you will get the answers actually. Everything is same. Instead of 800, 400 degrees Celsius. Correct. So efficiency, second law efficiency 67.3, and first law efficiency, yes, correct, that is 58.3. So 313 divided by 673 you will do. Okay. 53, yes. Okay. Just check the calculation part again. This is second law efficiency. If I have to write the first law efficiency here, I will write it like this. First law efficiency 1 minus TL. So 313 divided by 673. Okay. So 313 divided by 673. 313 divided by 673. It is 1 minus 0.465. So answer you will be getting 1 minus 0.465 as 53.535, or we can say 53.5%, like this. Less than 1. No issue. I got it, Aditya. Maybe in hurry you have commented. No issue. Correct. All the data you have matched. So answer, if you see, which option will be correct? Which option is correct? Irreversibility, because first part is the irreversibility, second part is the second law efficiency. Which part is correct? Which option basically? Option D. Option D will be correct, right? Because the irreversibility answer that we have solved is irreversibility answer 178.3 minus 120, and the second law efficiency 67.3. So 178.3 minus 120, if you do, it is coming around 58.3. 58.3, and efficiency is 67.3 na. Second law efficiency. Correct, absolutely correct. Now moving to the next problem. This is also one of the most important problem, very important problem, right? Again asking irreversibility, but they have given data for the like a properties of pure substance. So properties of pure substance mixed with the irreversibility part here. So multi-concept problems you can expect in the GATE examination also. So you have to be very clear regarding the properties of pure substance. This is a very important chapter which many students will skip. But if those concepts were involved in the heat and work transfer cases, irreversibility cases or entropy cases, then in that case they might consider the question is difficult, but actually it is not. Please understand properties of pure substance is the most important concept. If you have understood that part, Rankine, Brayton cycle, VCRS, all topic will become very easy for you, right? So let us try this particular problem. I will give you 3 minutes for this question as well. Okay. Take 4 minutes, no issue, but try to solve it. We have to find entropy at that dryness fraction. No, see, condenser wet steam is, they have mentioned with quality. So that is what the quality with which it enters into the condenser and leaves the condenser as saturated liquid. They are asking the irreversibility. Irreversibility, you will be getting what? Atmospheric temperature will be multiplied. Yes, correct, absolutely, Aditya. Irreversibility is T naught into delta S universe. Yes, so delta S universe you have to calculate. Absolutely correct, Aditya, your approach. Just do it fast, this particular problem. So first what you will do, Aditya, entropy change of condenser, entropy change of surrounding, and then you will add, you will get the delta S of universe actually. Okay, and then you will get the answer of irreversibility as well. Delta S of condenser, entropy change of condenser, then entropy change of surrounding. $729, no, 729 is not correct. Just check your calculation. Time up. Now see, let us see the problem here. This is the condenser they have given. Entry and this is exit. So let's suppose this is first point. Information they have given, entering at as a wet steam 0.1 megapascal and 0.6 is the quality. Okay, dryness fraction is 0.6. What about 2 kg per second as the mass flow rate? Now very important point, leaves the condenser as saturated liquid. It is leaving it as a saturated liquid. So this is condition 1, this is condition 2. So H2 will be written here as C, as HF, because saturated liquid they have mentioned. It will be HF. If I have to write S2, it will be SF. Right, like this. Now they have given the dryness fraction, so we can calculate enthalpy as HF plus X HFG. Okay, in a similar way we can calculate S1 also, SF plus X SFG. Is it clear? H1 and S1 like this. Now what is the values they have given? At 0.1 megapascal HF value they have given 417. 417.4 plus 0.6 is the dryness fraction. HFG 2258.1. Now entropy values we will write here 1.3029 plus 0.6 into 6.0573. 6.0573. Is it correct, everyone? H1, S1 we have mentioned, and what about the values? Because it is working at constant pressure, so same values we can write it here. HF value will be 417.4 and SF value is 1.3029. Correct. So first of all, this H1 value and S1 values. H1 value, what is H1 value? So entropy you have mentioned as 4.9. 4.9272. 4.9272, and what about the enthalpy value? Please tell me that one also. It is approximately, just cross check, 1772.26, and this is coming around maybe small change because of calculation you have done. 4.9373 it is there. 4.9373. Now see, this is the condenser, this is what the change, entry exit like this. Entropy change of a condenser, how you will write? Entropy change for condenser, M S1 minus S2, simple. Entropy change of surrounding, M H1 minus H2 divided by temperature at which it is working. Yes, why to find the enthalpy? Because surrounding, how you will calculate the entropy change of surrounding? Because the fluid is entering into the condenser. In the condenser, what will happen? Heat rejection. It will reject the heat. How much heat it will reject? H1 minus H2, difference of enthalpy only. To get the answer of entropy change, we have to divide by temperature. Obviously, T saturation. Why directly we can divide by temperature? Because it is constant temperature. At constant temperature, it will be there, na? Phase change is happening. Pressure and temperature, both values are constant during the phase change. Pressure and temperature, both will remain constant during the phase change. That's why H1 and H2 values are important here. Correct? So, individually you will be getting two answer. Okay. Now, finally, delta S universe. Delta S of condenser plus delta S of universe. You will be getting, and finally irreversibility is T naught multiplied by delta S universe. Calculate everyone. Do it fast now. Tell me your answers now after this. What will be the answer now? It will come around like minus 7.26, approximately minus 7.2687 kilowatt per Kelvin. And second one is coming approximately 9.0324. 9.0324 kilowatt Kelvin. Like this. Okay. Just put the values here, delta is universe, and then T naught you need to multiply. T naught temperature they have mentioned already. Okay. Atmospheric condition 27 degrees Celsius, that is 300 Kelvin. Now what will be the answer finally? T naught is 27 degrees Celsius. So final answer of irreversibility. Tell me your answer. $529, yes, absolutely correct. Kilowatt. 529 is correct. Option D. Correct, absolutely correct, Aditya. Superb. So I hope such kind of questions, when you are solving it, you will gain the confidence. See, in the GATE examination, confidence matters a lot, and confidence will come only if you are solving different variety of questions. Okay? Different variety of questions you should solve, then only the confidence will be there. Right? Now coming to the next problem. Yes, this one. Okay, I will give you the hint here how to solve it. Take 3 minutes. Or better take 4 minutes, no issue. But hint is Clausius-Clapeyron equation. Hint for you is Clausius-Clapeyron equation we have to use here to solve this question. Use of Clausius-Clapeyron equation. Clausius-Clapeyron equation. This equation we will use, and basically we will modify this equation. Last 20 seconds. Uh, 17.23. No, answer is 1.22. Now see how we will use this relation. See, first of all, if I talk about VF volume, it is much smaller compared to volume of VG, right? That is the first point we need to understand. Volume of the saturated liquid compared to saturated vapor, if you compare, saturated vapor will be having much higher volume compared to saturated liquid. That's why we are writing like this. Second thing, that saturated vapor considered as an ideal gas. Right. So what I will do in the relation, see, dP by dt it is there, HFG by T. Now consider as an ideal gas, so if I use the relation PVG equals to RT, so VG will be written as RT by P. This value I will substitute here. Okay, in this relation I will put the value of T VG. Instead of VFG I am writing VG only. Now see, that VG value if I substitute here, there will be a small change in the formula, and that final formula you should better remember this one. Okay, HFG R into RT by P. Okay, RT by P, like this. Now what will happen? This P will come here in the denominator. HFG by R is separated. DT by T square. Integration we are going to perform. Is it clear? So that P goes to the numerator. Here it on the left side it will come in denominator. DT will go to that side. DT by T square. Integration we have to perform here. So like 1 to 2. So ln P2 by P1 after integration HFG by R 1 by T1 minus 1 by T2. Like this it will come. Is it correct? Done. Now just you need to put the values, you will get the answer very easily. Okay, final pressure they are asking now. So initially pressure was 0.8725. What was the HFG value? 24891. 248.9 divided by R value. R value was 0.4615. The temperature initially 5 degrees Celsius. Okay, it is 5 degrees Celsius. They have mentioned directly that we can use it here. Okay. Now tell me what will be your answer after this. 5 degree and 10 degrees Celsius they have mentioned. Just put the values and tell me your answers. $278 and here it is 283. What is the answer of P2? Now what is the answer of P2, Aditya? Tell me. Now what will be the answer of P2? Just put the values and tell me your answer of P2. And this formula you should directly remember. You should add this formula in your notes. Directly it is very important. Directly you should remember this one. Please add it in your notes, guys. P value approximately 1.22 kilopascal it will be coming. Okay, 1.22 kilopascal approximately. Done. I hope this one is clear to everyone. Right, we'll move to the next problem. Yes, this one. Exergy destroyed, they are asking. Okay, take 4 minutes, but try to get the answer correctly here in this case. This is also like one of the important questions from the Exergy topic. Do it fast, everyone. Aditya, next question, tell me what will be the answer. Exergy destroyed. Exergy destroyed is nothing but the irreversibility only. Sometimes you might get confused also. What is Exergy destroyed? It is nothing but the irreversibility. Ashok is saying option B. Aditya is saying 16.6. No, option B is not correct, and even 16 is not the correct answer. Please cross check your calculations. Ashok, check your calculation. Check your calculation, everyone. Last 30 seconds. Time up. Now see, I don't know like what mistake you have done, both of you. Just see the solution here. Insulated rigid tank. Okay. It is insulated and rigid tank. Means heat transfer is 0. Rigid tank means what? Volume will remain constant. You need to understand this point first of all. Option A. No, option D is correct. 11.87. Ashok, see. This now the data they have given 150 kilopascal and 0.5 kg it is there. First of all, mass. Then pressure. What is the pressure they have mentioned? 150 kilopascal. What about temperature? 20 degrees Celsius. Now, a pedal wheel inside the tank is now rotated by an external power source until the temperature in the tank rises to 55 degrees Celsius. Because there is a external work done on the system from the pedal wheel. Work is supplied to the system. And because of that, yes, option D, Ashok, correct. Option D is correct answer. Because of the external work done on the system, what will happen? The temperature increases to 55 degrees Celsius, right? Now, they are asking the exergy destroyed, or maybe they will change the word as irreversibility, right? Because irreversibility is the lost potential. Okay, so that's what to please practice well, and please while doing calculation you have to be very careful, so that because of calculation mistake you should not get the wrong answer. So it means like you have done everything correctly and the last small calculation mistake and you are getting negative marks. So that is the worst scenario. You should avoid that thing, and that will only happen with maximum practice. More you practice, more accuracy you will be having, right? And the speed part will also improve with more practice of test series. Now, first of all, delta S of universe, if I have to write, it is delta S of system plus surrounding. Delta S of surrounding is 0 because there is no interaction happening from system and surrounding, will be 0. Is this point clear, everyone? Now, delta S of system, how you will write? This is very important. M CV ln T2 by T1 plus M R ln V2 by V1. Again, volume constant, that part will also become 0. So directly mass, they have given 0.5, 0.718 for an ideal gas, CV value ln 55 plus 273, and initially temperature was 20 plus 273. From here delta S system you will be getting, which is ultimately equals to your delta S of universe. So Exergy destroyed is nothing but the irreversibility or lost potential, T naught value multiplied by delta S universe. So what will be the answer? Option D, 11 point something you will be getting, 11.87. Correct, 11.87 will be the answer. Aditya, is it clear? You got the answer? Aditya. Okay, we'll move to the next problem. If you have any doubt related with this problem, you please ask. Okay. Now, next thing, find a rate of work into the heat pump. This is again like we can say multi-concept problem. Same thing you did. So maybe some calculation mistake you have done. That's why you didn't get the answer in the first attempt, I think. Right. Now this is like a multi-concept problem. Okay. They have mentioned 60 kilogram per hour of water runs through a heat exchanger, entering as a saturated liquid and leaving as a saturated vapor. For that heat exchanger, heat is supplied by the heat pump. $16.53. No, just cross check. 11.87 it is coming. Aditya, just cross check it. What is that? Surrounding temperature 20 degrees Celsius only. 11.86 it is only coming. Okay. So, see, that's what I'm telling you. If it is an air, by default you should remember the values. Okay, no issue. Now, for your clarity purpose, I will draw the diagram so that you will understand how to solve this question. There is a heat exchanger in which entry is happening as a, what is going to enter here? Saturated liquid. And it is leaving as a saturated vapor. For this heat exchanger, heat is supplied by a heat pump. Okay, obviously heat pump we have to supply work input. So that work input they are asking. No, Aditya, you cannot use MCP. The formula for constant volume process is, see, how you will write MCP ln T2 by T1. MCP ln T2 by T1 will not be used. For constant pressure process, you will be writing MCP ln T2 by T1. Aditya, is it clear? If you use MCP ln T2 by T1, then you have to write pressure also, because see, this is also you should write for an ideal gas. Delta S formula for any process is mCV ln T2 by T1 plus mR ln V2 by V1. For any process, forget about the constant volume, any process. Another formula, mCP ln T2 by T1 minus mR ln P2 by P1. These formulas are applicable for any process. Yes, correct, absolutely, Aditya. Now, solve this question. Okay. This is really a very good problem, guys, from the multi-concept. Try everyone this question. Yes, minus R ln P2 by P1. Try this problem, everyone. Aditya, Ashok. $6.15 you are getting. No. That is not correct. 1.615. Ashok, maybe somewhere you have done mistake in the calculation only. I hope from the diagram you have understood how to approach this question, right? Last 30 seconds. Now see how we will solve this question. First of all, this is a heat exchanger. Entering fluid is saturated liquid, and when it is going to exit, it will be saturated vapor. So please understand here, and one more thing, the important information they have mentioned, pressure 200 kilopascal. For 200 kilopascal, so here what is the value of HF at the rate 200 kilopascal, and here value will be Hg at the rate 200 kilopascal. Now apply basic energy balance. QH is going to be supplied. So what I will write, M1 H1 plus QH equals to MH2. So take this one as H2 and take this one as H1. Is it clear? So M1 H1, right? They have given this information. I found efficiency through the temperature and then heat rejection through HF and Hg. Correct, correct. Yes, Ashok, that is what we have to use. Absolutely correct. Now, if I talk about the QH value, because this QH we have to calculate now first. So, MH2 minus H1. Can you tell me this QH value? 60 kilogram per hour. 60 divided by kilogram per hour. 60 into 60. H2 value. H2 value will be 270. 6.7 minus H1 504.7. Can you tell me QH answer first of all? 352.32. Is it correct? So 2706.7 minus 504.7 into 60 divided by 3600. 36.7 it is coming. Oh, without mass you have solved. Ashok, see, that is what small silly mistakes that will happen in the GATE examination. How without mass you can solve? QH answer is coming as 36.7 kilowatt. 36.7 kilowatt it is coming. Now using COP formula of heat pump, TH by TH minus TL equals to QH by work input. What is TH? TH will be the temperature at which heat exchanger is working. What is that one? 120.93 degrees Celsius. Okay, that will be, see, this is 120 plus 120.93 plus 273. 120.93 plus 273 it is there. That is 393.93 divided by 393.93 minus TL. TL, what they have mentioned? Low temperature reservoir 16 degrees Celsius. Okay. So that is 289 QH, just now we have calculated 36.7 and work input from here we will be getting. So this 393.93 minus 289. Okay, and this multiplied by 36.7 divided by 393.93. Correct. So what is the answer? 9.7 something it is coming. Yes, Aditya, correct. So if you skip the mass part, see actually what happens, no, this kind of mistake happens when we are not carefully thinking about the units. If you think about the unit partner, then this mistake will not happen. So 9.7 will be the correct answer, 9.77 approximately, or 9.78 we can write. So always remember, Ashok, take care of the unit part. Whatever you are writing, that unit should be clear to you. It should not be directly I have written the formula, I am just putting the values. Just make sure whether unit is coming correctly or not. Unit part, if you take care, then such mistakes will never happen. Okay. Now, next this question. I hope you are enjoying the session of thermodynamics. Whatever questions we are discussing, this is totally new questions, right? Apart from PYQ, we have to solve multiple variety of questions. Then only you will become confident, right? So that is what very important part in the GATE preparation. More you will practice, more confident you will become. Otherwise, whenever you will read the theory, you will always think you know everything. But whenever numerical part comes, you will struggle a lot. If you just read on theory part, read the formula sheets, read short notes, you will always feel that I know everything. But when the numerical part is coming, when you have to solve numerical, then actual struggle you will face. So that's why more you will practice numericals, more clarity about the topic also you will be having. Okay. So just try to solve this question, everyone. So this is from the Brayton cycle. This one is from Brayton cycle. Ratio of the net work output to turbine work. So what they are asking? This ratio they are asking. Around 3 it is coming. Let me check your answer. No, it is not around 3. It is around 0.54, 0.54 it is coming. Yes, Aditya, correct, absolutely correct, 0.54, absolutely correct. So last 10 seconds. Now see how we will solve this question. So first of all, let's suppose the curve, TS curve for the Brayton cycle if I draw. 1, 2, 3 and 4. 1 to 2 compression, 2 to 3 heat addition, 3 to 4 expansion and 4 to 1 heat rejection, like that. So this ratio we have to find out, net by turbine. So net is nothing but turbine minus compressor. Okay, correct? Is it clear, everyone? So which will be nothing but 1 minus compression work by turbine work, which will be written as like this. One minus compression work. So compression is from 2 to 1. So H2 minus H1 divided by turbine work, H3 minus H4. Right? So obviously Cp delta T it would be there. How we will write? 1 minus T2 minus T1, T3 by T4. So what I will do, I will take common T1 from the numerator and T3 I will take common from the denominator. So T2 by T1 minus 1, here 1 minus T4 by T3. Right? Now why I have taken T1, T3 common? Because maximum minimum temperature they have mentioned 300 and 1100. So this is, if we can write here directly T3, so better write it here, and T1 was 300 Kelvin. Now you need to understand here 1 to 2 isentropic process it would be there, 3 to 4 also isentropic process. So for 1 to 2 process I can write T2 by T1 as P2 by P1 to the power gamma minus 1 upon gamma. P2 by P1 is the pressure ratio which is given as 6 in the question. So T2 by T1 as 6 to the power gamma minus 1 upon gamma. Correct? Now they have mentioned simply the air, so we will be taking accordingly the value of 1.4 for the, see 1.4 already given if it is ideal gas which is air here. So 1.4 is the gamma value. So T2 by T1 fine, okay, we got the value. What is T4 by T3? That we have to see. 3 to 4 again isentropic process. So here I can write here simply T3, okay, T3 by T4 as P3 by P4 to the power gamma minus 1 upon gamma. So T3 by T4 value is Rp, that is 6 to the power gamma minus 1 upon gamma. Right? Correct. Now these values we will substitute here, but here T4 by T3 is there. So what I will do, 1 upon Rp to the power gamma minus 1. So as we have written net work by turbine work as 1 minus T1 by T3. Here it is, okay, directly I will write in terms of Rp gamma minus 1 upon gamma divided by 1 minus 1 upon Rp to the power gamma minus 1 upon gamma. Rp value already it is given as 6. T1 is already given 300. T3 is what? 1100. So answer you will be getting approximately 5.4. That is what the answer. I hope the solution part is clear to everyone. Is it clear? Ashok, you also got the answer? Ashok, did you get the answer or not? Because you were saying around 3. It is not around 3, it is 0.54. So I hope the solution is clear to you, right? Fine. Now, moving to the next problem. That is from the Rankine cycle. Okay. Make sure that you are drawing the right diagram, then only you will be getting right answer, because the diagrams are very important here. So take 4 minutes, no issue, but give me the right answer here. So read the question very carefully here. In Brayton cycle, Rankine cycle, in VCRS cycle, important part is the diagram and the processes. After that, it will be very easy. Okay. So just try this one, everyone. Last 1 minute, everyone. Last 10 seconds. Okay, now look at the solution part here. See, Rankine cycle they have mentioned. So let us first draw the curve here, temperature versus entropy. So 1 to 2 and then 3 and this is 4, or you can write it from here also, 1, 2, 3 and this is 4. 1 to 2 turbine expansion, 2 to 3 it is in the condenser, 3 to 4 pump and then 4 to 1 heat addition in the boiler. Aditya, you are getting 40.4. Okay, let us see this part. Information they have given 10 megapascal and 10 pascal, 10 megapascal and 10 kilopascal it is working. Between this pressure 10 megapascal and 10 kilopascal. Now the data they have given, enthalpy and entropy of saturated liquid at 10 kilopascal they have given like this, and enthalpy of vaporization and enthalpy of enthalpy of vaporization and entropy of vaporization both they have mentioned. But enthalpy and entropy inlet to the turbine is 33751. So basically H1 they have given 33751. S1 they have given also. What is the S1 value? 6.5995. 6.5995 like this. Now first of all, to get the efficiency, thermal efficiency, we need to use this formula, net work done divided by the heat added. Okay, or directly I will write heat added here. Net work is turbine work minus pump work. Pump work they have asked to neglect. Heat added means H1 minus H4. What is turbine work? H1 minus H2 divided by H1 minus H4. So H1 already we have. H2 how I will calculate? For that dryness fraction is required. Yes, Aditya, dryness fraction is required. To calculate the dryness fraction, what you will do? S1 equals to S2, isentropic expansion. S1 already we have 6.5995. S2 value, SF value at 10 kilopascal. Enthalpy of saturated liquid they have mentioned as 0.6492. 0.6492 plus X, okay, into their SFG value, that will be given as 7.4996. So from here X value you will be getting, with this X value you will be getting the answer of H2, which will be HF. What is the HF value? 191.8 plus X into HFG. What is HFG value? They have mentioned 2392. 2392.1. Correct. So you will be getting H2 value. H2 value we have substituted, then easily you will be getting the answer. H4. What is the H4 value? Tell me, what will be the H4 value? H4 is nothing but at 10 kilopascal saturated liquid. So that is given as 191.8 itself. It is nothing but HF corresponding to 10 kilopascal, like this. So yes, dryness fraction 0.79. Yes, absolutely correct. 0.79 it is coming, 34 to be precise, 0.7934. And I will directly write down the values. H2 is coming as 2089. Okay, 2089.69, and that thermal efficiency is coming as 40.3%. Correct? Yes, absolutely, Aditya, your answer is correct. Superb. Great. Superb. You have solved all the values correctly here. Right? Very good. So that's how we have to maintain this level of accuracy. It's not all about you whatever formulas you know, like whatever formulas you are able to remember, whatever the concepts you are having, that doesn't guarantee that you will get right answer. Right answer you will be getting with practice only. whoever going to write the gate examination, everyone knows the formula. It's not like you only know the formula, everyone knows the formula, but only few people are able to get the right answer, only those people which they have done, those people who have already done lot of practice. Please understand this point. Otherwise, every people who are writing gate examination, little bit preparation they are doing, they know the formulas, but still not getting answer because they have not done the practice, and definitely there will be lot of mistakes happening with them. But if you have done lot of practice, you know that there are the chance of mistakes. You will be very careful while doing those calculations, and you will do minimum mistakes. I'm telling you, your focus should be more on how many questions you are attempting, and as well as whatever questions you are attempting, that should be right. If you are having more than 90 or 95% accuracy, you will be getting a very good marks in the gate examination. Problem is, we are attempting more and more question, but we are doing many mistakes as well. So that part we should understand कि mistakes are more, then there is no use of solving more questions. Make sure whatever number of questions you are attempting, that should be right, and attempt only those questions in which you are confident. Otherwise, there is no use. You will be wasting time also and still not getting marks. So before attempting any question, read the question very carefully. If you are getting a confidence, yes, I know how to solve this question, previously I have solved similar kind of question, then only you should solve initially. If any question you find it very different or very difficult, you are not able to understand how to approach it, immediately skip that question in the test, in the gate examination. Don't ever try any new question initially. Your first focus should be on attempt all easy problems, so that at least you will gain the confidence, and later on all difficult questions you will try in the whatever time is remaining there. I hope you have enjoyed this particular session of thermodynamics. One more session I will be taking on theory of machine as well. So if you really like the session, do share and like the session, and you can subscribe to IMS Gate Academy YouTube channel also. Before ending the session here, I just want to inform you regarding test series part here. IMS Gate Academy launched the test series product, right? So this test series product is very, very important. Exergy topic questions I skipped in preparation. So Aditya, Exergy part is very important. Don't skip that one. Okay, theory of machine you can attend. You will get the notification. Just subscribe to the IMS Gate Academy YouTube channel. You will get all the notification regarding upcoming sessions as well, right? So that test series plus product you will be getting, and as of now 20% off is there, in which you will be getting more than 130 plus sessions, 130 plus tests you will be getting. Apart from that, 2 previous year booklets. One will be for aptitude and mathematics, second for technical one. And more important part, at this point, many students are facing lot of problems in the numericals. For that, doubt solving portal is there. You can access the doubt solving portal at any time. You can post n number of doubts there, and you will get the solutions immediately, right? So these are the features that you will be getting. Apart from that, post gate guidance program and all this features you will be getting in the test series plus product. Okay, now next part that we are having here is the Telegram group. You should join the Telegram group, because all the latest notification, job related notifications you will be getting here, and whatever YouTube lectures we are conducting here, you will be getting all notification, as well as the PDF of our sessions also. This complete PDF of this particular thermodynamic sessions and all upcoming gate booster sessions you will be getting in this Telegram group itself. You can directly join the Telegram group, because there is a link provided in the description. Click on that link, you can join, and you will get all the important notification and the information there itself. And finally, Gate 26 batches already started in the IMS Gate Academy live online program, where you will be getting more than 800 hours of sessions. And most important feature is the 12 mentorship sessions, where you can directly connect with the faculty, and wherever you are facing challenges or the difficulty during your preparation part, faculty will be always with you. He will help you out, and it will try to resolve all your difficulty or the whatever problems you are facing, right? So Aditya, timing will be 4 to 7 only. Timing will be 4 to 7. You will get the notifications. If you just subscribe the IMS Gate Academy YouTube channel, notifications you will be getting. Apart from that, in Telegram group, you will get all the notification of upcoming sessions itself. So that's why Telegram group also you should join, and you can subscribe directly YouTube channel. Okay. So if you are interested in the counseling session, please you can call on this number. There will be a free counseling session. You get all the information related to the classes of IMS Gate Academy Live 26. Okay Aditya, we'll meet on the theory of machine session. Thank you so much.